Just go, Rita?
Yeah,
Jump
yeah,
back?
go ahead.
Brilliant. Okay, and we'll start recording.
Right, welcome everyone. Our seminar is finally getting started. I want to kindly remind that there's no scheduled fire alarms, so if you do hear one, run away. The assembly point is just by the street at the crossing. So welcome all the attendees in the room and the virtual room to our Dalton seminar series, AP300 Small Modular Reactor. The seminar is hosted in Old Fellows Hall, home of the Dalton Nuclear Institute. We bring together the skills and expertise of the nuclear research community at the University of Manchester, create opportunities to grow the scale, scope, and quality of university's nuclear activity, support the development in Manchester's nuclear research capability, and foster interdisciplinary collaboration. The Dalton Seminar Series covers a range of nuclear topics, bring guest speakers together with expertise from all across the university. It is hosted by Dalton champions who are doing nuclear-related research, representing many departments like me. I'm studying for my PhD in fusion material. So if you would like to be a Dalton champion, please do let us know. So today we are excited to have Dr. Rita Barenwal with us. As Senior Vice President, Dr. Rita Barenwal leads the development and deployment of the AP300 SMR. She has over 25 years of nuclear industry experience. Dr. Barenwal was Chief Technology Officer and Senior Vice President of Digital and Innovation at Westinghouse, where she led company's global research and development investments and spearhead a technology strategy to advance the company's innovative nuclear solutions. Previously, Dr. Barenwal served as Chief Nuclear Officer and Vice President of Nuclear at the Electric Power Research Institute. She had overall management and technology responsibility for the R&D activities, supporting over 80% of the world's commercial nuclear fleet. Before that, Dr. Barenwal served as Assistant Secretary for the Office of Nuclear Energy in the U.S. Department of Energy, in a U.S. President-appointed and Senate-confirmed role. She led efforts to promote R&D on nuclear technologies that sustain the U.S. fleet of nuclear reactors and enable the deployment of advanced nuclear energy systems. Dr. Barenwal also served as Director of Technology Development and Application, Core Engineer Director, and Materials and Field Road Design Manager at Westinghouse. Dr. Barenwal has a bachelor degree from Massachusetts Institute of Technology in Material Science and Engineering, and a master's degree and PhD in the same discipline from the University of Michigan. Welcome, Rita.
Thank you. Thanks for that. And now it's 2:00, so nice meeting you. If you would like to come up, please do. Yeah. And so thanks for the introduction. Thanks for having me on such super short notice. Thank you, Adrian, and team for having coordinated this. It's really nice to be back here. Actually, my role as manager of materials and fuel rod design at Westinghouse actually brought me to Manchester. We were part of the music program. If anyone's familiar with that, there's a plutonium irradiation program. And I worked very closely early in my career, and she's now a mentor with Professor Gracie Burke, and then the late, great Professor Mike Burke was a good friend of mine as well. So really good to be here. And I'm going to tell you a little bit about Westinghouse and our AP300 small modular reactor, but I am happy to spend the rest of this hour talking about whatever you want. As you can tell from my bio, I can't keep a job. So we can talk about that. We can talk about leadership. We can talk about whatever you would like. So let me pause there and see if you do want me to go through my prepared content or just have a conversation.
We do the prepared.
Okay, let me do the prepared stuff and then we will go from there. All right. Maybe we won't. My,
Oh, it's working
Yeah.
online, but not in there. Is that connected to the?
I think it's to do with mirroring of the screen, because it's connected to Zoom and this screen, I think. It's,
okay,
Okay.
slow and steady. All right. So briefly, Westinghouse was founded by the George Westinghouse in 1886. We are responsible for the world's first commercial PWR. There's some debate, but I'm going to go with we are the deployer of the first commercial PWR. And that was at shipping port, actually just near my hometown at the moment where I live. And I live in Pittsburgh, which is near Shippingport, Pennsylvania. Westinghouse is responsible for some of the world's greatest advances in engineering, but also specifically in nuclear energy. And we certainly are a key partner in solving the global energy challenge. We're over 137 years old, and our presence around the world is shown here in the green countries. We have more than 9,500 employees at more than 90 different facilities in 21 different countries. Important to the UK, we have one of our 3 fuel fabrication facilities just down the road. That's where I was yesterday, actually in Preston. Springfields is where we fabricate fuel, as well as in the city of in Columbia and South Carolina in the United States, and the city of Västerås in Sweden. Very proudly, we're the original equipment manufacturer or technology provider to more than half of the world's operating nuclear power technology. So it's a pretty big impact that we have. So let me talk a little bit about the Springfields fuel facility. It's over 75 years of research, engineering, and fuel production. It's gone through several different owners over the decades, but it's now run by Westinghouse. So we're gonna talk about it in that context. And we have more than 1,000 highly skilled workers that are employed not only at that site, but then around some other sites in the UK. It is National Apprenticeship Week here in the UK. Westinghouse has several different apprentice opportunities, and I think I have that at the last slide. You all are probably already affiliated with the university, but still I would encourage you, if you have colleagues, friends, neighbors that might want to be part of this program, let them know that this is the time to apply. And I'll end my talk with that. Our fuel fabrication facility has been making nuclear fuel for the world since 1946. It provides finished products as well as uranium recovery services for our customers. And about 1/3 of the UK's low carbon electricity or clean energy comes from fuel that was fabricated at Springfield. So that's a pretty substantial amount of impact here for the UK. And if you think about how how critical, how vital that facility is to contributing to a clean energy economy, it's a really big impact for something that has, I would say, only 1,000 employees there. And then the domestic fuel supply to support future large reactor development, as well as SMRs, is really key for the growth out of that facility. They're looking to also produce reprocessed uranium, as well as high assay low enriched uranium, which is vital to a lot of the Gen 4 reactors to operate. So without fuel, you can't do anything in nuclear power. So this is a very key resource for the UK. I put this slide in because sometimes it's really hard for folks to, when I talk to the general public a lot as well, it's hard for folks to understand what that means when we talk about emissions free or CO2 reduction. So this graph kind of shows Westinghouse has 3 reactor products that we offer. There's actually 4, but one's still in development, and that's the lead-fast reactor. So we have our AP1000 gigawatt size plant, we have our AP300, and our eVinci microreactor. And I'll talk a little bit more about that in a moment. But the 1,000 megawatt plant avoids 7 million metric tons of CO2, or AP300 avoids 1.85 million tons of CO2 annually. And the 5 megawatt eVinci reactor, which is not this big, sorry, but it's a microreactor. It avoids 55,000 metric tons of CO2. Again, sometimes those figures don't resonate with people. So I also like to talk about how many homes it powers. 750,000, about 200,000, or about 5,000. And also talk about the equivalent of cars taken off the road, not EVs, but internal combustion engine type of cars. So 1.5 million cars taken off the road, or 400,000 cars taken off the road, or 10,000 cars taken off the road. All right, so why is nuclear important? So the two major facets of and benefits of nuclear power that are of vital interest to communities today are its ability to decarbonize and the energy security and energy independence it provides. So our AP1000 reactors, currently there are 4 operating very successfully in China. 2 more are being constructed, and additional, the number keeps going up every time, but more are planned for construction in China. The US has 1 successfully operating already. The second one is due to come online literally any day now. So keep your eyes open for Vogtle 4 to come online in Georgia in the United States. Poland is our next large construction project. They have contracted for 3 AP1000s. The Ukraine has contracted for 9. Bulgaria has contracted for 2, and India has selected us for 6. And you don't need to see that one again, so let's go this way. Okay, so several years ago, I was actually at an SMR conference, and I was talking about SMRs because that was the nature of the event. And this engineer stood up and she said, "Why are you talking only about SMRs? Do you think that's all I can afford?" And I said, "Absolutely not." So now I talk about wherever we, depending on what role I'm in, but still, nonetheless, I talk about the portfolio of reactors that we have for any community or any end user. And the end user can select what type of product they need and what fits their budget, for example, as well. So there used to be a phrase, there's an app for that. I like to say we have a reactor for that. So if you need a gigawatt scale reactor, we have a reactor for that. If you need 300 megawatts or so of output, we have a reactor for that. If you only need 5 megawatts or a combination, multiples of 5, we have a reactor for that. Regardless of what type of reactor you might need or community might need, we also have long duration energy storage as a product. And it's pretty elegant because it doesn't rely on critical minerals or rare earths. It's oil, water, and concrete. So when I went to Australia and spoke about this. Australia currently has a ban on nuclear commercial power, which is ironic because they're part of AUKUS. So it's the tide may be turning for them. But I talked about this entire portfolio as well as long duration energy storage, and everybody's ears perked up when I talked about this because it could be coupled with solar and wind, which is what they're really pushing there. All right, so oh boy, let's try this. Let's see how it works. So this is an actual drone video. And is this no, I need to do something here. New share?
Yeah, share the screen as opposed to sharing the.
Let me do the new share. Okay, here we go. Is there just a oh, here we go. Button.
We can see it on the online one, so it may.
Okay, so just a bit of a lag.
Have you pressed play?
No, I haven't.
Oh, okay, yeah, so online it's working. It's just not working in this screen.
All right. Share sound.
Yeah. On Zoom, are you sharing?
It says you are screen sharing. Let me stop share.
Yeah, maybe stop share and then share.
And then share again.
Okay, but now this screen is just not changing. Oh, so okay, yeah, and yeah, because that's got number 2, so that's the second screen.
Yeah, you need to
This is
mirror
the
it
issue.
with the-
Can you mirror your screen as opposed to extending it? Because on Zoom it's fine. It's just this screen is an extension of your.
Oh, it's an extension.
Rather than a mirror.
Okay, let me see. Now you're asking me, at this point, my kids would be like, this is why you're no longer chief technology officer.
That's what- Yeah.
Windows P should bring up the options.
Okay,
And then
so
you can
just
duplicate.
duplicate, thank you.
Yeah, there we go.
All right,
Sorted.
now, so we'll do that. What is this? No, 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 no. Shouldn't it get out of there? There we go. Alright, well, there is sound with this, but it's not. So, yeah. But this is an actual video. What is an actual video file? It looks like a this is Google. These are 18,000. So let me stop that and then back to my. Dalton. Okay, and the reason I showed you that is that our.
Yeah, I
Okay.
think this, maybe
You need to flip the two screens, but you can see your
No, no,
full presentation on
on
there.
Zoom, I think now it is mirrored, so it's fine.
Okay, so how
So
do I
maybe
just get
change
to
that. I
like the
think
regular? I just wanna
Just,
get-
what's the left button? The one next to it, what's that do? Oh, no, okay, don't press that, press it. There we go.
I kind of do have it memorized, but I still need to, yeah, all right.
It was shared, it was shared.
Yeah, maybe it was another share, so maybe just stop sharing and just sorry. Go back to the PowerPoint. Exit the end of the slideshow.
Display set.
Yeah, try that.
Display
settings, then stop presenting.
It's recording everybody. Oh my goodness.
If you end slideshow and go back in.
And just go in
Yeah,
as
I think
a,
that's the easiest thing.
and then
Right,
just
and
do
now if you
this.
start that and then share that, I think that will be fine. And but we need to share on Zoom as well, sorry.
You've left the start menu now, start button.
Yeah, but I just don't want it in this mode because this is what you're gonna see.
No, I think it's over.
No, we're seeing.
Okay, you're seeing
Yeah,
it
yeah.
perfectly.
So
Okay,
it's
so
just-
now just do escape.
Yeah.
Or
Just go to Zoom.
Yeah.
Sorry, I will do. It's the same, I had the same problem so many times. It's this one, right?
Dalton, yeah.
Yeah. Okey-dokey, share. Should be fine.
So me.
It's a shared screen.
No, it'll just do the same as, I think we have this problem with it, it's fine. As long as you can see.
Okay. So our SMR is actually based on our gigawatt AP1000 technology. So I'm going to talk a little bit about that, and that's why I showed you the video. AP1000 is a Generation 3 plant. It has fully passive safety features, which means that it's truly walk-away safe for 72+ hours. You need no operator interaction, no human intervention, no diesel backup generators for the safety-related system. It has an optimized design that uses advanced modular construction, so you can factory fabricate a lot of the components and then assemble them on site. We have steel and concrete composite for the containment building. So we have steel panels that are shipped and then filled with concrete on site. It's licensed in the UK. It's gotten the GDA certification. It's licensed in the US and it's also licensed in China. Despite it being a new technology, which you would think would have some glitches as you go through the first few years of operation, these plants are setting operational records. The availability, or the capacity factor for these reactors is about 93%. The outage time, or the refueling outages, are very, very minimal in days, saving plants up to, I think, $11 million. So the shortest outage, I believe, was on the order of just over a dozen days. Every day that a plant is down for an outage, it costs the operator $1 million. So the fewer days that you can be down, the better. And then, of course, all of the benefits afforded by nuclear power, safe, clean, reliable energy. In addition to providing electricity, AP1000 is the first use of nuclear power in China to provide district heating to its communities. So over 200,000 people in the community of Haiyang are receiving district heat that is coming off of the AP1000 plant in that community, which is really important to get them through these winter months. But it's notable that it's the first actual use of nuclear power for district heating. It can also be used to desalinate water. It can be used for hydrogen production, and that's a very, very hot topic right now. So that's a benefit. And then I already talked about the energy storage capability, which can be used with any of the plants. So this is another schematic, and you're going to see this again. Basically, you plug the heat source in over here, and you can produce hydrogen, process heat, district heating, and desalination, and then of course couple that with our long duration energy storage product. I have a video on AP300, given how much trouble it was. It's in here, you can look it up on YouTube, it's really slick. It is an artist rendering, so it's not like a drone flyover, because we have not constructed one of these yet, but it's in here, so take a look if you're interested. But our AP300 technology is based on now over 21 AP1000 reactor years of operation. This number will keep going up as those AP1000 plants come online. We have over 30 years of research and development and licensing that's gone into this technology. And most notably, the safety-related footprint for this small modular reactor is less than 0.4 acres. And I do have another schematic that I like much better, so it's coming up. It's based on proven technology. So this is kind of a cutaway of what the AP1000 will look like. What's notably different between AP300 and AP1000 is that the spent fuel pool is inside containment, and that allows us to shrink that footprint even more for the safety-related aspects of the plant. Another benefit is that because we're using traditional fuel, it's low enriched fuel, 495 or lower percent enrichment. We've only just shortened it a little bit because we don't need as much power output. And we're using adopt pellets, which is a doped alumina chromia fuel for those that are familiar with fuel. It improves the fuel economics and allows for going to high garnup should a plant want to do that. What else do I want to talk about here? The cooling water sits up top or in the event of an accident. The cooling water relies on natural convection and gravity, and it would come down from the top over the containment. All right, so this is my favorite graphic for showing the size of our AP300 reactor. It's about 1/4 of a football pitch, and when we compare it to some of our competitors, the amount of land that is needed per megawatt is only 5 meters squared. And you compare that to some of our other competitors, and it's much, much smaller. So it's much more compact, which means that it can be put closer to urban centers should a community want that. And it's going to cost less because you're going to require less land per megawatt. And then when we compare PWR technology to BWR technology, to boiling water reactor technology, the main benefit is not only the compactness, but also the exposure to personnel. Minimize exposure to personnel with the PWRs, as well as produce clean steam that can be used for those beyond electricity benefits. So hydrogen, process heat, district heating. The versatility uses non-radioactive steam compared to our boiling water technology. So this is the graphic that shows you the cutaway of some of the safety features. There's that gravity drain water tank that relies on natural convection, steel containment vessel. We have redundancy and defense in depth for aircraft impact regulations. And I already talked about the fact that it is walkaway safe and it is self-sufficient. So we're taking a passive approach to safety that, again, eliminates the need for a cooling supply and backup power. All right, so a question I often get asked is when can we have one, right? Well, it's not a widget, it's not an iPhone, it's not gonna come out next year. It's gonna be readily deployable in about 10 years. We are working with the regulator here in the UK as well as the regulator in the US. But we've got the technology readiness. It's based on AP 1000. We have as close to licensing certainty as possible. I can't presume that ONR is going to approve this, but we're working with them on communicating often, just as we are with the US NRC. So we have more licensing certainty, I would say, than some of the other technology developers or vendors out there. The reason I actually came to Manchester was we had a supply chain workshop event yesterday, and it's going on today as well out in Preston. And we have worked very hard to reestablish the supply chain that is needed to deploy new nuclear. Part of the reason for some of the cost and schedule overruns that have been seen with new nuclear projects, including ours, is because we had a dormant supply chain for new nuclear builds. And so Westinghouse, along with many other partners, has worked hard to reinvigorate that and fortify that. And frankly, shame on us if we let that become dormant again. So we need to make sure that we keep deploying new nuclear, which the need is out there. If you follow the news, the need is absolutely out there. So you all are in a very good field. But we need to make sure that we engage the supply chain. Part of the conversation yesterday was around, can you engage us as you're going through this design process so that we can either tell you, yes, we can build that, or we can build it better if you make these tweaks to the design. So there's a lot of collaboration that will happen even in that design phase so that we make sure that it's manufactured, or it's designed to be manufactured as optimally as possible. This is a little bit more about that supply chain. We talk about innovation, smart innovation, where we're trying to drive down costs in the AP 300 compared to AP 1000 is through innovative technology. So I talked about the adopt fuel pellet. There's some INC advances. So there's a few different aspects, but those are all in the spirit of taking new information, new processes, new materials, and applying them and improving the AP 300. The modular construction feature is similar to AP 1000, but in addition, we're going to have what's called engineering rooms, and those are going to be modularly constructed as well, and then brought to site. And so this is the AP 300 version of that schematic for versatility of application. So you've got the reactor here, hydrogen production, process heat, district heating, water desalination, and then also long duration energy storage. So in summary for the AP 300, it's the only SMR that's based on an nth of a kind operating plant. I talked about the plants in China, the plants in the US. It's based on proven technology, advanced safety, and it is readily deployable. And I told you I would end with a slide on the apprenticeship program. So here in the UK, we have been supporters of the apprenticeship program since the 1950s. It is very important to our workforce and the workforce development program that Westinghouse has. Over 2,000 engineers and business professionals have come through the program. Ideally, we want them all to stay with Westinghouse, but if they don't, understood. But the program has really strengthened our legacy while also creating leaders. The deputy managing director out at Springfield came through the apprenticeship program. So it's a really good example of learning the skill, going to school, and then making your career out of that move. So, like I said, if you have folks in your circle that are interested in this, the applications are currently open for advanced engineering, nuclear engineering, digital and software degrees, lab technicians, and business managers as well. So I would encourage you to share that information, and hopefully we'll see folks. Now, what's interesting is that the interest in the apprenticeship program has really skyrocketed. We had, I think the number of applicants continues to increase year over year, and now we're at a point where it's about more than double the number of applicants that we had probably 2 years ago. So it's a good sign for us, for sure. But it is selective now at this point. So thank you very much for your attention. Again, happy to answer questions about this or anything else that you want to talk about.
Thank you Rita, for the enlightening presentation. So we're now open for questions or conversations.
This is gonna be a slightly multi-part question.
One question per person. I'm just kidding.
You can probably guess where I'm going with the first part. Will it run on MOX?
It is at the moment not designed to run on MOX. We do have, so our lead-fast reactor could run on MOX, which is Gen 4 concept.
And the flip side of that, would you be kind of open to discussions about closing the fuel cycle with the AP300 as part of it?
I would say we're always open to it. It's a tricky conversation for sure, but it's yeah, sure, we're open to it.
I know it's been a kind of a moot point in the US since they put the kibosh on it, what, late 70s,
Yeah.
early 80s.
Yeah.
And since we shut Thorpe and B205 down, we've kind of kept the knowledge base there with AFCP. But the government is still kind of, you know, they really don't want to commit to it, but might not. But we're still looking like 2040, 2050.
Yeah.
Before we kind of get to that stage. But I guess if you're basing it on PWR technology, you don't need that much by way of modifications to swap from a full UO2 core to a partial MOX core, or even a full MOX core. Like the EPR was designed for that standard. I know the French are running their Gen 2, Gen 3 reactors on partial MOX cores.
No, I don't know where the fuel needs to get qualified as well, just as the plants do. So what's the status of MOX qualification here? Is it, I assume it's qualified by the ONR?
I honestly have absolutely no idea.
Okay.
The UK government's approach to our plume stockpile is kind of, again, saying reprocessing, just kind of sit on it and wait, I guess, much like the spent fuel storage
Okay.
thing. They just want to wait and see.
Yeah. And so I'm not even familiar with what the status is in the US with the NRC for MOX.
Yeah.
If it's not qualified, then it would need to first go through that fuel qualification program, which is not a inexpensive step. And then one would weigh the balance of what's worth the trip.
We collaborated on and off with Idaho and various other institutions in the US. So there seems to be kind of a will to keep the skill base alive, so that you could bring a closed fuel cycle back if you wanted to. But again, the action of government seems to be kind of again.
But like I said, our lead-fast reactor can close the fuel, can use fuel and close the fuel cycle, can use reprocessed fuel as well. So absolutely, it's in our portfolio. It's just not with these three nearer term reactors.
I'm interested in this argument about economies of scale versus economies of multiples. For the AP300, how many do you think you've got to make before you get like really good at it?
So those are two different questions.
Yes,
right? I would say.
I was circumventing the one question.
So, well, let's talk about the economics first. Or sorry, the economies of scale first. If a community is looking for a gigawatt of output, it's a no-brainer. They should go with an AP1000 versus 3 or so AP300s. The cost per megawatt hour is cheaper with the larger you go. The eVinci, it serves a very specific community. It serves communities that are right now competing with a very expensive cost of diesel. Or that need a portable reactor, and users that might need a portable reactor like the military, or space application. So it's not, it's more expensive per megawatt hour, but it's cheaper than their current, than the current alternative. How many do we need to make to be good at it? We're targeting nth of a kind for SMR to be between 8 and 10. We are now embarking on nth of a kind for AP1000 because the 7th and 8th are being constructed. So ballpark. And one might argue that actually, if we count our AP1000s in that AP300 construction cycle, then our second, third, fourth might be considered nth of a kind. I wouldn't, but one might.
I was going to ask about the SMR competition, the Great British Nuclear are running
Yes.
in the UK.
Yes.
And AP 300 is one of the 6 shortlisted designs for that. Can
Yeah.
you say a little about what your expectations are for hearing from GBN
Sure.
progress, and how hardwired your aspirations for the UK are to being successful in that competition?
So the UK is a top priority for Westinghouse. That short list of 6, so let me back up. GBN is a Great British Nuclear. It's a technology selection process that the government has put forth to down select an SMR technology. We think it's going to be 2, maybe 3 that get down selected from the 6, which is a very long short list, by the way, in case you were wondering. I think it's a very long short list. That said, I'm really excited because GBN was just launched last summer. So for them to have already put a call out and gotten their act together is fantastic, because this industry, if you haven't been in it too long, it's very slow. We're very conservative. We're very stodgy. So to do anything with haste is remarkable. We were supposed to get the proposal information right before Christmas. There's been a delay, and we were supposed to get it in early February. So maybe Friday we'll get it's called the ISET, but it's essentially, submit your proposal kind of language. What we've heard is that this information packet, I'm doing this because I've been told it's 2,000 pages. And we'll have about I think we'll have about 4 months to respond. And I joke with my team, like, it'll take us 4 months to read the thing. But anyway, so about 4 months to respond. Let's say it comes out soon. So that puts us at beginning of summer. And then I think GBN intends to have a further down select within the year, right? Within this calendar year. So by Christmas. So we'll know if we are in that mix of 2, maybe 3 competitors. Again, the benefit that Westinghouse has in its corner is that we have a very strong legacy in the UK. The fuel facility, the apprenticeship program. We're not just coming in and hoping that we win a contest. And I've been coached and slapped. It's not a competition, even though I think it's a competition. And I call it that in Rory chastises. It's a technology selection process, I guess, but it's a contest. So we have the fuel, the apprenticeship program, and we have a rich history here, and we're going to stay here. It's not that we're going to build and then leave. This is a century-long relationship when you deploy a reactor. And by the way, the AP 300 has an 80-year life. AP 1000 has a 60-year design life. So again, you've got a very long relationship that you will have with any entity that ends up using the reactor. So we're optimistic, but not complacent. And we're not assuming that we're going to be down selected, but we did start the GDA process, which is the regulatory process to get the design license. We submitted our intent. Well, the way it works is you send your application intent and the package to DESNZ, and then DESNZ works with ONR. So we started the process. Yeah.
Kind of a follow-up question to that, and if you can't answer it, just ignore me. But so there's likely to be an election here. This year.
I've heard.
Yeah.
Supposedly.
And maybe a change in government. Do you think that could affect the process with the down selection? And if so, are there any plans in place to deal with that?
I mean, given that we don't even know when the election will be, right? Oh, sure. Yes, it could affect. I hope it doesn't. And we have our government affairs team here in the UK that is very engaged with the appropriate folks. And so they're trying to just continue to highlight the good work that we're doing, the importance of nuclear in the country. And the UK is not going to get to its targets without nuclear. So I think hopefully, despite what the election outcome might be, that the focus on nuclear is still favorable. In the United States, for example, we have seen good support for nuclear. It's called, I would call it bipartisan support. And so I was in the last administration, which was Republican. The current administration is Democratic, and both are equally supportive of deploying new nuclear as well as supporting existing nuclear technology. What's interesting is the previous administration was focusing on the jobs that nuclear creates, which is great. And the current administration is focusing on the clean energy that nuclear provides, which is great. So it doesn't really matter what the driver is for the nuclear support as long as it's there. And I'm hoping that that will be the same here.
We've got a question on Zoom.
Yes.
Hi, yes, thanks for your talk. I was just interested in what you thought the comparison of the passage of AP 1000 through the GDA process will be with AP 300.
So if I understood the question correctly, how do those two reactor designs compare going through the licensing process? We're hoping, and I'm basing this on what I'm seeing with the US NRC. With the US NRC, we've started our private meetings as well as public engagement meetings. So you can see some of that content online if you care to go look. What we're doing with the US NRC is submitting white papers first on some of the changes that we've made from AP 300 compared to AP 1000. Then if needed, we're going to submit topical reports, which are actually more formal. White papers are just one way. Here's some information, read it if you'd like to understand what we're talking about. Before we submit every white paper, we have a pre-meeting or a pre-submittal meeting with the NRC to apprise them of what's in that white paper and make sure that the questions that they might have get addressed in the white paper. And then we have a public meeting as well. Now, in those private meetings, what's interesting to me is that the questions that are being asked of us are so deep that it seems to me that these are the same people that reviewed AP 1000's, the AP 1000 license, which is great because we're starting from a different level, a different baseline, if you will, with the review team, if that's true. I'm hoping that that will be kind of the analog with the review process, the GDA process with ONR. If you have the same teams or the same personnel that reviewed our AP 1000 GDA application, who are going to review the AP 300, that allows for just a lot more efficiency. If we don't, it'll take a little bit more time. That's okay. But also, I believe ONR is watching what NRC is doing, and they have said in a couple of different forums that they don't envision showstoppers that are going to be specific to the UK. They're watching what the NRC does, and hopefully they'll similarly follow suit in the review process. That said, each regulatory body has a mission to ensure the health and safety of the public, and they will do that, and whatever time that takes, it takes.
We have another question on
Yeah.
Zoom from Mike. Please.
Hi there, Rita. This is Mike Waite from Nairo. Nice to see you, and thank you for the chat.
Hi, Mike.
Yeah, I wanted to pick up on one of your slides where you talked about comparisons between PWR technology and AP 300 with the BWR technologies and some of the competitors in SMR space. And I thought it was a really important point about application versatility. I know in like large reactor power generation, you know, some folks like BWR, some PWR, but where SMR is looking to be far more versatile in what its output is it power, is it heat for district heating, is it heat for desalination, etc. That point that you made about radioactive steam seems really, really important, and you know, having that degree of separation between the fuel and other users, you know, is key. Could you expand on that at all?
Not too much, actually, but it's a good question for me to take back and get a little bit more information on and expand on that. What is interesting, though, is that for PWR, for pressurized water applications, that clean steam is of great interest to very unique end users to the nuclear community. I don't think I would have said 10 years ago that this industry would be talking to the likes of Exxon, BP, Total, that those Microsoft, right? Google, some have appointed heads of nuclear, others are exploring nuclear to add to their portfolio. And that clean steam is one piece of it, including manufacturers of just any sort of industrial application, but specifically those that need that can benefit from clean steam for those applications. So there's an outfit in industrialist, if you will, in Poland, who has decided to deploy SMRs to power all of his manufacturing sites, tires, cement, ceramic tiles. Fabrication of these of these products need reliable electricity, and that clean steam can help with process heat for those applications.
You have one more question.
Oh yeah, it's me again. I think you commented during your talk that the CNI, I&C, I think you said, would be different from the AP1000 to the AP300. Any knowledge of how different that will be?
It won't be too different, and I believe we have not yet submitted the white paper on that one. Again, it'll be updates, but recall that AP1000, it's been several years since it's been licensed, and there's been a lot of, I would say, innovation in that space since, year after year in the digital I&C space. And so we would just apply what those updates are and what the benefits, the improvements are, again, using innovation to drive down costs for the deployment of the reactors.
Sorry, does that mean that the fundamental equipment might well have changed?
No. So the fundamental equipment won't necessarily change. We're trying to minimize any changes to any safety related equipment because it gets us through the licensing process faster if there are no changes to safety related systems.
Thank you.
It should be myself, I have a question. So you said AP300 will be more portable, and then you have micro reactor design, which is more portable, like sounds like to be installed in a naval application. And then you have a force design. I'm not sure whether it's going to be more portable to be inserted into a car or vehicle.
No. So to be clear, AP300 is not portable.
Yeah.
So that's the one. eVinci could be portable. It's a 5 megawatt reactor. It's a heat pipe reactor, sodium heat pipe reactor. It is of interest to remote communities, islanded communities, military applications, and space applications. The fourth reactor design that we have is a lead-fast reactor concept. It is in between an SMR and a gigawatt. It's 450 megawatts. So it is also not portable.
Right.
But if you all are interested in a smaller reactor that could be put into a car, let's talk. Because again, Westinghouse has always been at the forefront of innovation. And some of those much smaller reactors have been conceptualized and then in some cases tested. But the timing wasn't necessarily right, or the technology wasn't right. There's been so many advances, not only with materials, modeling and simulation, digital twin, all of that, that when people ask, well, we tried molten salt, decades ago, why are we trying it again now? Well, now we have sensing technology and better corrosion resistant materials. So there's a reason why some of those things that were tried before now being attempted again with those improvements in all of the systems.
Right.
I like another one.
Okay.
Completely different from that one. I hadn't realised that the AP300 design included spent fuel storage within the primary container. So two-part question, how much fuel can be stored in there? And secondly, is the driver for that to reduce the size of the emergency planning zone to help the SMR be more flexibly sited near to industrial?
The second part is yes.
Okay.
And I believe it's 2 reloads worth that can be stored there. And then the intent is once they're full, they're cast and then shipped for.
So there's no other spent fuel storage within the
No.
design, it's within the primary container.
And then cast, yes.
Okay,
Yeah.
thank you.
So we still have time for 1, 2 questions.
Yes.
I'm guessing you've hidden the steam generator and the pressurizer in the bits on top of the core, is that correct?
I don't know if they've finalized it. They've been working with the layout because also the compactness is great on paper. But we can't have 3-foot humans relying on our 5-year-olds or 3-foot humans to go through. So we need to make sure that they're spaced and at least there's room to maneuver for maintenance. And so right now, I think the team has completed the conceptual design, and I'm not sure if they've finalized where the pressurizer and the steam generator, what the placement is.
Let me take the last question.
Okay.
Because I'm not from like nuclear fission background,
Right.
but I know there's a fast reactor design. It's not a famous one. It's not a popular one, right? Isn't the fast reactor? Is that this your force?
The lead reactor is a fast reactor.
Okay, so why do we still need the fast reactor design? Is it just because the energy supply level is in between 1,000 and 300, or is the technology is better? Also, why do we still need the first?
So there were several different reasons. One was to close the fuel cycle. You're not going to need to use as much fuel because you can use reprocessed fuel and close the fuel cycle. The other is that it can be operated at hotter temperatures, and you can produce higher quality steam, and then all those other ancillary benefits. There's a lot of different manufacturing processes that rely on much higher temperature steam, and our lead fast reactor can provide that. And the third reason was back when we launched the lead fast reactor project at Westinghouse, we did so to try to compete with the cost of natural gas in the United States. And so those were the 3 major reasons.
Right. Thank you. So I believe it.
Yeah.
I'm wondering the cycle length of AP300.
So we are, so it's a 3-year fuel cycle, which is better than AP 1000. It's 18-24 months. So 3 years is what we're averaging. It depends on also what the customer wants, because there are outages that have to occur anyways. And so some may say, well, if I'm already going in there, why not go ahead and refuel as well? So we have different assessments of 2 years, 3 years, even 4 years. And what's interesting, and this is something that the university might be able to help with, the reason that we are actually not pursuing a very long refueling cycle is that we don't have irradiation data, long-term irradiation data on zirconium, on the grid materials, on not the fuel, not the cladding itself, but the grid materials. So I think it's a great research type of collaboration project that we could probably embark on, looking at the long-term irradiation effects of zirconium that is kept in core for long refueling cycles. That's what's holding us back right now.
What's the enrichment level, or is it still 5?
It's going to be it's less than 5, so it could go up to 495, but for the 3-year refueling cycle, we're actually, I think, looking at 395. So that's what allows us to keep the fuel in for that long. Don't quote me on that because I don't know, but I know it's less than 495. Yeah.
What kind of burn up do you reckon you'll be able to get with that level of enrichment?
Say that again.
What kind of burn up? What levels?
Oh, I don't have that off the top of my head. Yeah, we do have it in one of the topical or the white papers.
Okay, I think we are closing the seminar now with great thanks. Let's give a big round of applause to Richard. And thanks for all the participants and hope to see